Let us imagine ourselves 5 billion years back in time. In the outer part of the Milky Way, there floated an immense cloud of gases and dust. Gradually, the swirling cloud began to condense in some places, forming several disks. One of them was the solar nebula, from which our solar system was to emerge. Almost all the material in the nebula was pulled into the center, where it formed a new star, the Sun. Out of what was left, a few smaller bodies took shape far from the Sun. These became the planets and their moons. By about 4.5 billion years ago, the solar system had formed. That's the theory, but we don't know exactly how the Sun and its family came into being. We know more about the evolution of stars than we do about our own origins. Why? Because enormous changes went on in the early history of the solar system. Chunks of matter, left over from the condensing disk, bombarded planets and moons. Some of them melted and later cooled into solid rocky bodies. Other planets became huge globes of gases and liquids. These dramatic changes are like a curtain that hides what we want to know. How did the solar system really form? From our observatories, we look for clues in the night sky that will help us draw back that curtain. One group of objects in particular may give us some of the answers we're looking for. They are the comets. Occasionally, one of these lonely wanderers passes near the Sun. Then, night after night, sometimes for weeks, a comet blazes a glowing path across the sky on its journey around the Sun and back to deep space. The astronomer reaches out to the comet with instruments, wanting to understand it better. For scientists believe that comets may still contain particles of the original cloud from which the solar system condensed over 4.5 billion years ago. If that is so, then comets may be our best chance to discover how the solar system came into being. Comets have long been part of humanity's history and legends. A medieval artist associated a comet with a joyful event, the birth of Jesus. But usually, comets were seen as evil omens. Misfortune would surely follow them. People feared these mysterious streaks in the night sky, believing they were symbols of God's anger. But a few saw them as part of the natural world which they wanted to understand. Through careful observations, scientists of the 16th and 17th centuries discovered that comets orbited the Sun. Edmund Halley, an English astronomer, was one of these scientists. He tracked the great comet of 1682 and realized that this same comet might have been seen many times in the past. He predicted that it would return about every 76 years. Some thought the idea was ridiculous, but the comet's next return proved that Halley was right. When this comet, now called Halley's Comet, returned in 1910, millions of people were fascinated by the heavenly spectacle. Scientists studied the comet closely, and it was photographed for the first time as it orbited the Sun and disappeared into space for another 76 years. What we know about comets is limited by what we've observed from Earth. Over 500 comets are well known, and with the help of computers, we can plot some of their orbits around the sun. Here, the computer first draws the orbits of the outer planets, then the path of a comet. Some comets come from enormous distances and may take several million years to circle the sun. They may appear only once in our night sky before escaping from the solar system. Nearly 100 comets have short periods, meaning that they return in less than 200 years. One comes back every 3 years and 4 months. Here the computer shows the motion of a comet called Tempel 2. Notice that it speeds up as it approaches the sun, then slows down again as it moves away. A comet may approach the sun from any angle. Halley's comet, for example, orbits the sun in the opposite direction from the planets. Some comets never go beyond the orbit of Jupiter. Others, like Halley, travel nearly to the edge of the solar system before the sun's gravity pulls them back. The motions of comets are relatively simple to compute, but even the best Earth-based instruments can't reveal the exact composition and structure of comets. For this reason, our present knowledge is mostly theory. The evidence we have suggests that at the heart of a comet is a nucleus of ice and dust, the largest probably not more than about 30 kilometers across. The nucleus is what scientists would like to study most. As the comet moves closer to the sun, gases and dust begin to boil off, forming a diffuse cloud called the coma. The coma may get to be 100,000 kilometers across, and it practically hides the nucleus. The coma blends into the tail, the most spectacular feature of a comet. The tail grows longer as the comet moves closer to the sun, and always points more or less away from it. That's because the sun's energy acts like a wind that blows gases and dust away from the comet's nucleus. A comet's tail may extend for tens of millions of kilometers, farther than light travels in 1 minute. But with each trip around the sun, a comet loses some of its substance. Eventually, a comet dies. Yet, even as old comets are consumed, new ones continue to enter the solar system. But from where? If we could travel away from the sun, leaving all the planets behind until they disappear into the blackness of space, and until the sun itself is just another bright spot in the sky, we would find a thin cloud of objects enveloping the solar system. These are the original comets, billions of them scattered across half a light year of space. They have been here unchanged since the beginning of the solar system. Occasionally, one of these comets changes direction, perhaps because another star passed nearby, and begins its journey toward the sun. Hundreds, perhaps thousands of years later, it may become visible from Earth, still carrying clues about the early history of the solar system. Recently, we began sending spacecraft to explore other planets and moons, hoping to add to our understanding of how they were formed. Every such voyage has added immensely to our knowledge. and has tantalized us with new puzzles. One day we may be able to study a comet at close range, and so get answers we can get nowhere else about the origin of the solar system, and perhaps even about the origin of life on Earth.